In our next problem, we're going to look at graphing linear inequalities. Let's graph each set. We have the set of all x such that x is less than 4. We have a single variable. We can use a number line in order to graph this. On our number line, we're going to designate our value of 0. If we move to the right, we have our positive values, 1, 2, 3, 4. If we move to the left, we'd have negative values, and I'll just put a couple. Now, the value that's pertinent to this expression is the value of 4. We notice that we want all of our values that are less than 4 on this graph. 4 is going to be the border between the solutions and the non-solutions to this inequality. So we're going to take our value at 4 and we're going to put an open circle. Now, it's open because we want to begin there, but we don't want to include that. If we want values that are less than 4, that requires us to move to the left on the number line. All of the values that are going to be indicated will be values that are smaller than 4. So for instance, if we choose a point that is in the shaded area, such as 1, we know that 1 is smaller than 4. Let's go to our second example. The set of all x such that x is greater than or equal to negative 2. Once more, let's draw a number line. We'll label values 0, 1, 2. Moving to the left, negative 1, negative 2, negative 3. The border is going to be at the value of negative 2. We'll start at negative 2. This time, notice that we want to allow our x value to equal negative 2, which means that when we draw it, we'll have a circle that we shade in, including that point. Now we want our x values that are greater than negative 2 also shaded, and that requires us to move to the right on the number line. And that would be a graphing of that solution set. And finally, we have the set of all x such that negative 4 is less than or equal to x is less than 1. Again, we begin in the same manner. Designate 0. We have 1, 2. Moving to the left, we can write negative 1, negative 2, negative 3, negative 4. The values that are pertinent to this solution are negative 4 and positive 1. At the value of negative 4, we want to draw in a closed circle because we see that we want to allow x to equal negative 4. At the value of positive 1, we're going to draw in an open circle. Now, for our number x to be between negative 4 and 1, we need to shade in the region which is between the two circles that we've drawn. And there's our graph. Here's another problem dealing with linear inequalities. Solve and graph the solution set for the inequality 5x minus 3 is less than or equal to 17. To solve this, we're going to start in the same manner we would as if this were an equation. That is, we want to isolate our x value. We can begin by adding 3 to both sides of the inequality. 5x minus 3 plus 3 is less than or equal to 17 plus 3. We'll end up with 5x is less than or equal to the value of 20. Next, to solve for x, we're going to divide both sides of the inequality by 5. When we divide by 5 on both sides of an inequality, our inequality symbol remains the same. We're going to have x is less than or equal to the value of 4. And now, in order to graph this, we'll draw a number line, label values as we move to the right, label a couple of values as we move to the left. The border will be at the value of 4. We want to allow our x value to equal 4, so we'll draw this in as a closed circle. Our solution set will be values that are smaller than 4 or equal to 4, so we'll shade in to the left. And this graph will designate the solution set. Here are a couple more linear inequalities for us to solve. Solve and graph the solution set. Part A, 1/4 x is less than 2. To solve for x in this inequality, we can see that right now we're multiplying by 1/4. To isolate the x, then, we would have to divide by 1/4. A division by 1/4 is the same as a multiplication by 4. So we can look at this as 4 multiplied times 1/4 x is less than 4 multiplied times 2. On the left-hand side, 4 multiplied times 1/4 is 1, leaving us with x. On the right-hand side, 4 times 2 gives us a value of 8. Now we're going to graph that solution set. On our number line, we need to put down values that are pertinent to the solution. Now we can sit here and draw in 0, 1, 2, 3, 4, 5, 6, 7, 8, or we're going to take a shortcut now. We know that 8 is going to be to the right of 0, and it's going to be the other value that's important to us in this solution set. We always want to make sure that we graph 0. We want to have 8 as our border. Since we don't want to allow x to equal 8, we'll draw that in as an open circle. And now we want values that are smaller than 8, and that requires us to shade in to the left. Our arrow indicates that continues. Let's go to the second one. Negative 6x is less than 18. In this problem, we're going to have to isolate x by dividing both sides of the inequality by negative 6. Now here's where inequalities are different than equations. When we divide by negative values, we switch the inequality symbol. So at the point that we are doing the division on both sides of this inequality by negative 6, this inequality sign, instead of being less than, switches to greater than. We then simplify to give ourselves x is greater than negative 3. Let's graph that solution set also. We'll have the value of 0. We need also the value at negative 3, which would be to the left of 0. We're going to graph an open circle at negative 3, and this time we want to shade in values that are larger than negative 3, and so we're going to shade in to the right. Let's now look at a little more complicated linear inequality. Solve and graph the solution set. 7x minus 3 is greater than 13x plus 33. In this linear inequality, we have the variable x appearing on both sides of the inequality. We're going to, however, progress in the same manner as we would if it were a linear equation, and that is we begin by trying to put all of our terms with x on one side of the inequality. To accomplish that, we could decide to subtract 13x from both sides of this inequality. That would look like this. 7x minus 3 minus 13x is greater than 13x plus 33 minus 13x. Simplifying, we have 7x minus 13x, which will be negative 6x. We still have that subtraction of 3. On the right-hand side, we have 13x plus 33 minus 13x, leaving us with 33. In our next step, we can isolate our x term by adding 3 to both sides of the inequality. This time, instead of writing it down, we're going to do this mentally. If we add 3 to the left-hand side of the inequality, that eliminates the subtraction of 3, leaving us with negative 6x. If we add 3 to the right-hand side of the inequality, we end up with 36. At this point in the problem, we're going to have to isolate x by dividing both sides of the inequality by negative 6. To accomplish this, we have negative 6x divided by negative 6. Remember that when we divide by a negative value, our inequality symbol will end up switching to the opposite direction. So instead of greater than here, we're going to have less than. Negative 6x divided by negative 6 is going to be less than 36 divided by negative 6. Now let's evaluate. We are going to be able to divide out the negative 6, leaving us with x. And on the right-hand side of the inequality, 36 divided by negative 6 is negative 6. Now we're going to graph that solution set by drawing a number line. Let's label 0 on the number line, and we need negative 6. We notice that we want values that are smaller than negative 6, meaning that we'll begin at negative 6 with an open circle, and we will shade in to the left in order to get our solution set. Here's another problem dealing with linear inequalities. Solve and graph the solution set. 2 times x minus 3 minus 1 is less than or equal to 3 times x plus 2 minus 14. We're going to begin to solve this by simplifying each side of the inequality individually. We can do that first of all by using the distributive law of multiplication over subtraction with our first set of parentheses. We'll have 2 multiplied times x, which would be 2x, minus 2 multiplied times 3, which would give us 6, minus 1 will move down. That's less than or equal to 3 multiplied times x is 3x, plus 3 multiplied times 2 is 6, and then we have minus 14. Now let's combine our constants. We're going to have 2x minus 7 is less than or equal to 3x minus 8. At this point, we can note that we can put both values of x on one side of the equation if we allow for a subtraction of 3x on both sides. So we're going to have 2x minus 7 minus 3x is less than or equal to 3x minus 8 minus 3x. On the left-hand side, 2x minus 3x will be negative x. On the right-hand side, 3x minus 8 minus 3x will be negative 8. Next, to isolate the x term, we're going to add 7 to both sides of the inequality. We'll do this part mentally. If we add 7 to the left-hand side, we end up with negative x. If we add 7 to the right-hand side, we end up with negative 1. Now, we still haven't solved for x yet. At this point, what we have is a value of negative x less than or equal to the value of negative 1. In order to get x by itself, we have to divide both sides of this inequality by the coefficient of negative 1. So negative x divided by negative 1. Now, division by a negative value requires us to switch the inequality symbol when we have negative 1 divided by negative 1. Simplifying, x is greater than or equal to positive 1. To graph this solution set, we're going to quickly sketch a number line. We need to label 0. We need to have on our number line the value 1. And we could put a few more values if we'd like. We can start at the value of 1 with a closed circle. And we want to shade in values to the right. And there's our solution set. In our next example, let's see how to work with a compound inequality. Solve and graph the solution set on a number line. 1 is less than or equal to 2x plus 3 is less than 11. In this compound inequality, we have 3 parts. We have a section to the left, a section in the middle, and a section to the right. Whatever we do to one section, we'll make sure we do to the other 2. If we're going to solve for x, think about what you would do if you didn't have the section to the left. Because we're adding 3, we could begin by subtracting 3 from that section. Therefore, we're going to have 1 minus 3 less than or equal to 2x plus 3 minus 3 less than 11 minus 3. Notice that we subtract 3 from all 3 parts. Now let's simplify. Negative 2 is less than or equal to 2x is less than 8. To solve for x, we notice that we can divide by 2. We'll divide by 2 in all 3 sections. Negative 2 divided by 2, less than or equal to 2x divided by 2, less than 8 divided by 2. So negative 1 is less than or equal to x is less than 4. Now that we have our x value isolated, we can graph this solution set. We'll draw a number line, label 0. We need negative 1. That's one of our pertinent points. We need the value of 4. Now, we do want to make sure that even though I'm not labeling everything between 0 and 4, that I have the correct spacing. So I don't want to do something that would be incorrect, and I'm just going to draw this over to the side because I've seen this done by students before. They'll put the 0. They'll say, oh, negative 1's over to the left and 4's over to the right. Well, this would be incorrect because you have the same spacing between 1 unit as you do between 4 units. So make sure you're not making that mistake. Back to our graph, we know that we need to have negative 1 included in our solution set. We know that 4 is going to be a border for our solution set but not included. and we want our values of x to be in between those two. And so here's our correct graph. Now let's consider an application using linear inequalities. To earn a B in a course, you must have a final average of at least 80%. On the first 3 examinations, you have grades of 82%, 74%, and 78%. If the final examination counts as 2 grades, what must you get on the final to earn a B in the course? In steps 1 and 2, we're going to represent all unknown quantities in terms of x. Well, in this case, we have just a single unknown quantity, and that is the grade we have to come up with on the final exam. So let's let x equal our score on the final, and we want to put that score in percent as we did have our other values. Now we want to write an inequality in terms of x that models the conditions. So what we're going to have is our first test, which is 82%. We'll write that in decimal format. We're going to add to that the score on our second test of 74%. We'll add to that the score on our third test of 78%. And now we need to add to that the score on the final, but notice that the final exam will count as 2 grades, so we will have to add it in as x plus x. Now we're coming up with an average. We have 1, 2, 3, 4, 5 scores, so we're going to divide by 5 to get our average, and we know that we want to end up with an average of at least 80%. At least 80% means 80% or greater. Therefore, our average needs to be greater than or equal to 80%. Now that we have that inequality, we need to solve it. So we're going to go ahead and simplify as we go. In our next step, step 4, solve the inequality and answer the problem's questions. We'll begin by adding together our percentages that we know. That ends up giving us 2.34 plus x gives us 2x. And we're dividing by 5, and that needs to be greater than or equal to 0.8. I'm just rounding off. I'm not rounding, but I'm leaving off the 0 in that expression. To solve this, we notice that we can multiply both sides of the inequality by 5. I'm going to go ahead and write that in here. We'll multiply by 5 on the left and multiply by 5 on the right. When we multiply by 5 on the left, our 5's cancel. We are left with 2.34 plus 2x. When we multiply on the right, 8/10 multiplied times 5 is going to give us a value of 4. Now, let's isolate our x term. We can accomplish this by subtracting 2.34 from both sides of the inequality. We're left with 2x on the left. That'll be greater than or equal to 4 minus 2.34 is 1.66. And finally, to solve for x, we'll divide both sides of the inequality by the positive value of 2, which will give us x is greater than or equal to, and when we divide here, we get 0.83. Now, this would then tell us that our value on our final exam would have to be greater than 83%. To check that result, we could take our 5 values, add them together, and find the average. So if we go back to our original setup, we have the value of 0.83. If we substitute 0.83 into this inequality, we're going to come up with exactly 0.8. If we take a value larger than 0.83, we should come up with a value greater than 0.8, and that's how we'll check.